All right. So in this video, we're going to start from number 11. We've got a fraction, 2/5 plus 3/7 plus a half. So the first thing we've got to do is to find the common denominator, the least common denominator. Now we've got 5, 7, and a 2. Now you could start with 7 and then try to write out the multiples. That is 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21. And then you check if 5 will go into these numbers and if 2 will go into these numbers. But with this, 5, 7, and 2, the fastest way to find the common denominator is to try to multiply the numbers, the denominators, I mean. 5 times 7 is 35. 5 times 7 is 35, which means 5 will go into 35, 7 will go into 35. But can 2 go into 35? No. So we do 5 times 7 times 2, which gives us 70. 5 times 7 is 35. 35 times 2 is 70. So you've got 70. So that is going to be LCD. So LCD is 70. Now we're going to make sure that we change these fractions to have the denominator of 70. So we're going to do that. Now 5 here times what gives you 70? 5 times 14. That is 7 times 2. 5 times 14 gives you 70. So we're going to multiply this by 14 over 14. Remember, 14 over 14 is 1. So I'm not changing the value of the fraction. Now, what about 3 over 7? 7, we have to multiply something by 7 to get a 70. 5 times 2 is 10. Or just divide 70 by 7, you're getting a 10. So we are multiplying by 10 over 10. And then we go to 1 over 2. 70 divided by 2 is 35. Or you just look at the 5 times 7. That is 35. So we multiply this by 35 over 35. So this should all give us denominators of 70. So I am going to go back to the first one. 14 over 14 times 2 over 5. So I'm multiplying that way. So I have 14 times 2 is 28 divided by 70 plus 3 times 10 is 30 divided by 70 plus 35 times 70. I mean 35. 1 times 35 is 35. 2 times 35 is 70. So we are multiplying that way again. Same thing here and at the bottom. So now we have a common denominator, so we keep the 70 and then we add the top. So we've got 28 plus 30 plus 35 all over 70. And that gives us 93 over 70. 93 over 70. All right. Number 12. Number 12. So in number 12, we have a long one. It's a very long equation. Minus 4 plus 4 x plus 7 equals 2x minus 3 minus 5x. So with this first one, you've got to use a distributive property. This you have to, this you have to. The 5x will stay because that you just have to hold on to it. So 3 times x is 3x minus 12 plus 4 times x is 4x plus 28. 2 times x is 2x. And then 2 times 3 is 6 minus 5x. Now, On the left, because I have some like terms like 3x and then 4x, I could add them, right? So fix your home first before you go into somebody else's home. So you're fixing your home. That is, fix everything on the left side before you look at the right side. The right side would also fix its own problems. So 3x and then 4x. Well, I want to group like terms. So 3x plus 4x. Now you don't change the signs because they did not cross the equal sign. Minus 12 goes with 28 equals 2x minus 5x minus 6. So on the right, I also had like terms, 2x and then negative 5x. So I bring them together. So I'm fixing the left and the right separately. So 3x plus 4x is 7x. Negative 12 plus 28 is positive 16 equals 2x minus 5x is negative 3x minus 6. So now I fixed the like terms on the left and then on the right. Now I have to look at the left and then the right. If there are like terms, they have to cross. Okay? So I've got 7x on the left. I've got negative 3x on the right. So I'm going to bring the 3x over to the 7x. And because it's negative, I'm going to add. So this and that. So I've got 10x, that is 7x plus 3x plus 16 equals negative 6. Now I'm solving for x, so x should stand alone. I'm going to move the 16 to the right. To do that, it's a positive 16, so I'm going to subtract 16. So I'm going to continue with that here. So I've got 10x plus 16 equals negative 6. So I'm going to subtract 16 and subtract 16. So 10x equals negative 6 minus 16. Now, negative 6 minus 16, it's like you check your bank account, you're at a negative 6, and you're taking more money out of the account. You're going to go more negative. It's like bringing two negatives together. You owe $6, you owe $16. Bring them together, you owe $22. So negative 22. And then you've got 10x. Now you divide by 10, you divide by 10. So x equals negative 22 over 10. Can I reduce this? Oh, yes, with a 2. 2 goes into 10 5 times. 2 goes into 22 11 times. So I've got negative 11 over 5. And that is my final answer. Negative 11 over 5. Okay, number 13. Number 13. Patient needs 60 mg of medication per kilogram. How many grams must you give to the patient that weighs 220 pounds? You are given a hint that 2.2 pounds is 1 kilogram. 2.2 pounds per 1 kilogram. Okay, so this patient is going to take this medication. It's 60 mg per kilogram, which means if the patient weighs 2 kilograms, you multiply the 60 by 2, which is 120. If the patient is 3 kilograms, that is a child, 3 kilograms, you multiply the 3 by 60 to get 180. That's how it goes. All right. But first of all, because we have the weight of the patient in pounds, we're going to change that to kilograms. We're going to change that to kilograms. You could use ratio and proportion, or you could use dimensional analysis. I'm going to do both. I'm going to do both quickly so that you follow. So let's say that I'm doing ratio and proportion. I know that 2.2 pounds is 1 kilograms. Because I have pounds on top, equals to 220 pounds, and then X kilograms. So pounds, pounds on top, kilogram, kilogram at the bottom. And then I cross multiply. 2.2 times X is 2.2X. 1 times 220 is 220. And then now I divide by 2.2. I divide by 2.2. So x equals 100 kg. That is, if you put that in a calculator, you should get 100 kg. Okay, so this patient weighs 100 kg. Now we go back to the top and then we are like, oh, so if the patient weighs 1 kilogram, you're given 60. This patient weighs 100 kilogram. So you multiply the 100 by the 60. And that's how we started with the problem, right? 2 kilogram, you multiply 60 by 2. 100 kilogram, you multiply that by 60. Or you could say that, all right, 60 mg is for 1 kilogram. Now I'm trying to find the mg's for 100 kilogram. And that's it. 1 times x is x equals 60 times 100. So this gives you 6,000 mg. 6,000 mg. Wow, 6,000 mg. But the problem says how many grams? So do not forget that this is in mg or milligrams. How many grams? So we're changing mg to grams. So this is where you have to remember your King-Henry stuff. Or if you already know that 1 gram is 1,000 mg, then that helps you. Okay, so whichever style you want to use, I told you that you would have to memorize the King-Henry stuff so that you could write it down on your scrap paper and then use it. If not, then you should remember that 1 gram is 1,000 mg. And we've got 6,000 mg. So you divide by 1,000, which gives you 6 grams. But if you don't know that, set it up. 1 gram is 1,000 mg, and we're trying to find x grams over 6,000. When you cross multiply, you have 1,000 times x equals 1 times 6,000 is 6,000. You divide by 1,000, you divide by 1,000. So x becomes 6 grams. X becomes 6 grams. All right, so this is ratio and proportion. If this is what you want, keep it. Keep it. All right. The next one I'm going to do on the same problem, I'm going to try to use dimensional analysis to do this problem. Dimensional analysis. So for dimensional analysis, we are going to start with the weight of the patient in pounds. Remember that you always have to write out the units. Now we know that 2.2 pounds is 1 kilogram. Because I want pounds to cancel, I'm going to put pounds here and then put kg there. So 1 kg is 2.2 pounds. So now I've moved to kilograms. When we did the ratio and proportion, we got 100. So from kilograms, I'm going to go to that, the medication. So I went from pounds to kilograms. And then now I'm going to go to mg. So 60 mg per kilogram. I'm moving to mg, so 60 mg per kilogram. I'm going to put kilogram here. This will cancel and then put mg there. And it's 60 mg per 1 kilogram. So now I'm at mg, which is 6,000, times, I've got to change from mg to grams. And we know that 1 gram is 1,000 mg. So I'm going to put that here. And then G. 1 gram is 1,000. So at this point, you have to multiply the top. 220 times 1 is 220 times 60 times 1. You write it down. So if you multiply that, the top, you should get 220 times 60. That should give you 13200 divided by, and then at the bottom, you're going to have 2.2 times 1,000 which will give you 2200. And when you divide this, this should, remember the mg's cancel out, so this should give you 6 grams, and that's it. All right. Number 14. Number 14. Number 14. So number 14 says there are 1.06 quarts per liter. So 1.06 quarts per liter. So I write that down. How many teaspoons are in 1 gallon? Then it tells you that there are 5 mLs per teaspoon and 4 quarts per gallon. Round to the nearest whole number. Okay. So in this problem, you have to know where you're starting from and where you're going. Create a road map. A road map. So I want to know how many teaspoons are in a gallon. So I'm starting from a gallon. So you could go from gallon to quarts because I have 4 quarts per gallon. And then from quarts, I could go to liters, right? Because I have the conversion here. So to L, and then from L to ml, and then from ml to teaspoons. Wow. So I've created my roadmap. It's just like going to the conversion chart and then looking at the conversions you have to solve this problem. But in the problem, it gives all of these to you. So you should know that, oh, okay, I'm looking at going from 1 gallon to teaspoons. To do that, oh, I have 4 quarts per gallon, and then I have quarts to liters because 1.06 quarts is 1 liter. So I use that. And then I could go from liters to mLs, and then I could go from ml to teaspoons. So 1 gallon in teaspoons. That's what the problem is asking. What is 1 gallon in teaspoon? So if I start here, 1 gallon is 4 quarts from this conversion rate. So this gives me 4 quarts. So I'm at 4 quarts. Now I've got to go from quarts to liters. To do that, if you're using ratio and proportion, you could set it up. Quarts to liters. I have 1.06 per 1 L. This equals 4 quarts, quarts on top, and then X liters. I cross multiply. Now, when I cross multiply, I have 1.06 times X, right? I write it down, 1.06 X equals 1 times 4, which is 4. And then I divide by 1.06, divide by 1.06. So X is going to be 4 divided by 1.06. 4 divided by 1.06. And that should give me 3.7736. So I'm going to do 3.774. 3.774. So X becomes 3.774. And I was going to liters. So 3.774 liters. So I'm here 3.774 liters. And then I'm going to mLs. I'm going to mLs. Now, from liters to mLs, you could use the King-Henry chart, or if you know that 1 liter is 1,000 ml, that helps you. You could set up as a ratio and proportion, or you use the chart. Liter is the base, so you're going to your right. You're going 3 times to your right, which means you're multiplying by 1,000, which means you're multiplying by 1,000. So you could use the chart, or you set it up as a ratio if you know that 1 liter is 1,000 mLs. You could also set it up that way. So 1 L is 1,000 ml. equals, I have 3.774 L over X. And then you cross multiply. 1 times X is X, so you've got 3.774 times 1,000. Wow, times 1,000. And that's why I said earlier, if you use the King Henry, you are multiplying 3.774 by 1,000, which gives you 3,774 mLs. Wow, so now we are right here, 3,744 ml. So 1 gallon is 3,774 mLs. Now we have to go to teaspoons. And in the problem, it tells us that 1 teaspoon is 5 ml. 1 teaspoon is 5. So because it tells us that, you could set it up as a ratio and proportion problem. So 5 mLs is 1 teaspoon. So this equal, I've got 3,700 that ml over x teaspoon. You cross multiply. So x times 5 is 5x. And then 1 times that is 3,774. You divide by 5, you divide by 5. And that should give you 3,774 divided by 5. That should give you 754.8 754.8. And it says round to the whole number, so that gives you 755. And that's it. That's it. That's it. This is when you are using the ratio and proportion problem. If this is okay for you, you could pause the video, go back, or try to do it by yourself, repeat it again and again so that you get it. If you want to use dimensional analysis, I'm going to do a dimensional analysis way too, so you follow. So let's see. So with dimensional analysis, here again, you have to know where you're going. So I have 1 gallon. And then I'm trying to go to quarts. So 4 quarts, it's 1 gallon. So I've got gallon here so that these will cancel. 1 gallon is 4 quarts. So now I'm at quarts because I canceled the gallons. Now I'm going to liters. Liters. Now 1.06 quarts per liter. So quarts, it's at the bottom. So I mean on top. So I put quarts here and then I put L there. And it's 1.06 quarts for 1 liter. So this will cancel that. So now I'm at liters. I'm going to ml. So L and then ml. 1 L is 1,000 mLs. So L will cancel L. And now I've got to go to teaspoon. So I'm just following the roadmap that I have here. Teaspoons, it's 5 ml is 1 teaspoon. Ml here so that they cancel, and then teaspoons at the top. 1 and then 5. So now you multiply the top. That is 4 times 1,000 because you've got 1, 1, 1. So 4 times 1,000, which is 4,000, divided by 1. At the bottom, you have 1 times 1 times 1.06 times 1 times 5. You multiply that too. And then you're going to have 4,000 on top divided by 5 times 1.06. That gives you 5.3. And this should give you the 755. And that's it for dimensional analysis. Okay, I'll see you in the next video. Thank you.